Okay, so you should jump to question 9. Okay, I talk about Form 4 Chapter 5. Okay, about question 9 and 10. So after question, I will let you to ask any question about Form 4 Chapter 5. Okay, so the graph 1 shows the electron arrangement of element P and Q. Okay, today's lesson just simply discuss some essay question about Form 4 Chapter 5. Okay, so about question 1 to 8, I already uploaded on my YouTube lah. Okay, so you can see lah, can watch. Okay, so I explain about like metallic bond, all this hydrogen bond and dative bond. Okay, question 1 to 5, I already uploaded on the shorts lah. Okay, then question 6 to 8, I just uploaded on YouTube already. Okay, so yeah, state the position of element P in the periodic table. Okay, if you see position, okay, or you see like kedudukan, so means they talk about the position of the, you know, your periodic table, right? So you got group 1, group 2, until group 18, right? So you got also like period 1, period 2, period 3. Group 1, group 2 is vertical column, right? Period 1, 2, 3 is horizontal row. Okay, so yeah, in this case, okay, if they talk about position, then they ask you for reason. Okay, call it alasan. Okay, in Malay. So position means you have to talk about group and period. Group in Malay is, you know, kumpulan, right? So in period in Malay is called kala. Okay, so P. Okay, if you want to know, if the question asks like this, right, you have to know the electron arrangement, or you call it susunan electron of P lah. Sometimes they ask you. Okay, so very simple. What you can do is you count lah. Wait. You calculate lah. Okay, how many electron? Okay, so first shell you got 2. Okay, P is 2 point. Total is 2.7. So P is 2.7. Q is 2.8.7. Okay, so one is 2.7, one is 287. So we already know lah. Okay, how do we know which group? How do we know which period? Very simple. Okay, so if the question asks, actually this one is related to chapter 4 a bit lah. Okay, so if you go like this, 7 valence electron, or we call it electron valence, then it is group 17. You already know. Okay, doesn't matter lah. Doesn't matter. Q is the same. P and Q, right? They have the same group, which is group 17. Okay, so that's why they are group 17. Okay, we call it kumpulan 17. Good. Okay, then for period, okay, before you have to explain why is it group 17? Because atom P has 7 valence electron. Remember, portion talk about what group and what period. Okay, in Malay you call it the kedudukan. You call it because it is low density. No, not density, but nothing you do low density. Okay, just that you talk about where are they in the periodic table, in the jadwal berkala unsur. Where? So we talk about, in Malay it's called kumpulan and kala. Yeah. Then period 2, 2 valence shell, yes. Yeah, kala 2, period 2, yes, because atom P has, because example, right, you have to be careful is, in answer, you better state like atom. So, even though it's small case, okay, small matter, but example important, okay, atom P, yeah, has 2 shell because they 1, 2, 2 shell. That's why if they ask about group or period, the first thing you have to know is what electron arrangement Apakah susunan elektron? Atau physical properties for group 17? Yes, correct. But they didn't ask this time. But they didn't ask. Yeah, because they asked for location. Yes, if they ask for physical property, in Malay called sifat fisik, then you can write down. Yes. For the answer, for low density, or you call it ketumpanan rendah, you can write down. But normally, I would say physical property, they ask less. Unless they talk about bond. Later I talk about bond. Yeah, 4 marks. 4 marks because group 1 mark, explain for group 1 mark, period 2 1 mark, explain for 2 shell also 1 mark. And sorry, just now somebody say valence shell, not valence shell. Shell only. Okay. You know what is valence? In Malay, say valence. Valence means the outside one. The outside shell, the most outside shell. We call it the outermost shell. Okay. We call it petala yang terluar. Okay. Not here. Not only one shell. We got 2 shell total. If they ask for Q, then it's still group 17, but period 3 because you got 3 shell. That's if they ask. Okay. Oke, unsur Q bertindak beras dengan wool besi panas membentuk pepecah perak. Oke, tuliskan persoalan kimia untuk menunjukkan. So, element Q react with iron wool, produce brown solid. Write the chemical equation. Okay, so in this case, very simple. Okay, so you know iron is Fe, right? So iron we call it ferrum. Besi is ferrum, is Fe. Okay, so you write Fe. Okay, burning, you are heating with Q. Okay, so actually, you know what is P? You know what is P? Who can tell me what is element P? P. Okay. What is P? Fluorine. Yes. No. Q only chlorine. Yes, fluorine. 2.7, 2.7 is fluorine. 287 only chlorine. After that, then only bromine, then only iodine. Yeah. So, in this case, but forget, and not forget, not forget. Remember, don't forget that, okay, in this case, if they say Fe react with Q, right? If you just write Q, then wrong already. This always, I saw students make mistake because they only write Q wrong. Remember, okay, you know that like oxygen is O2, chlorine is Cl2, fluorine F2, bromine Br2, hydrogen H2, nitrogen N2, right? You know this thing. But let's say if this Br, right, if this Cl, right, now they change to Q, you might forget. Okay, so you have to know what element first. You know this is chlorine. So chlorine, you should write Q2. Yeah. Sometimes I saw this question, then if the equation wrong, right? Sometimes they ask you to do calculation. Also, you get all wrong. Because you can't get the correct ratio of your equation. Then in exam, calculation also wrong. Because calculation also must have ratio, right? Like number of mole, then you find ratio, then you find the mass or volume. So that's why important is Fe plus Q2 become brown solid, or they call it pepecah perak. What is this? You know what is the cation ion? Fe become what? Become what charge? Who can tell me? Fe become Fe3 plus. Very good. Okay. So in this case, yes, it become Fe3 plus. Okay, Fe3 plus. And then what? This one is Q is what charge? My line so can. I upload this on YouTube. Can. I send the link later in group. Yes. Fe3 plus and Q minus. Okay, Q minus. Yes. So what is the formula? The 3 we give to Q, the 1 we give to Fe. I know some people already know how to write equation, but I also know some people still don't know. Okay, until now I also don't know. That's possible. So that's why it's Fe1, Q3. Always have to cross, just a reminder. Okay. Yes. And balance equation, right? So you know that because you got marks. But if you didn't balance, you will get 0 mark. So Q2, Q3, Q2 times 3, Q3 times 2, Fe times 2. Yeah, balancing can? No question? Asked? Yeah. So exam, normally if you see, if they ask you write equation, then the next question might be calculate number of mole, calculate bilangan mole. So you have to know. Yeah. Okay. But this one all a bit related to Form 4, Chapter 4. Okay. Okay. Because don't worry, maybe next week, like next Sunday again, I will do. Okay, maybe not next Sunday, because next Sunday is holiday. So maybe after next Sunday, I will do like chapter. Let me think. Form 4 chapter 1, or maybe Form 4 chapter 7, 4 chapter 8, possible. Because Form 4 chapter 6 we do in seminar. So I probably do other chapters. Okay. Okay. So unsur P and Q, okay, mempunyai sifat kimia yang sama. So it means they have the same chemical properties, but show different chemical reaction. Nah, compare reactivity of element Q and P and Q. 可的地方. So how to explain this one? You got 4 marks. So this chapter comes in exam. Which chapter? You mean chapter 4 or chapter 5? Okay. So, but this question, fluorine. Okay, you know, right? Okay. By the way, I forgot to tell you. Okay, actually, this answer, right? In case you ask me, wait, chapter 5. Chapter 5, I think it'll come out. I think it will come out. But I don't know if it come in essay. SPM came out in essay before. So only one time from your new syllabus. So I'm not sure your normal exam come out. Maybe, or even not come out, right? You come out like, sure, possible. I would say 90% you come out. Okay. So in this case, your answer can be also like this. Since you know Q is already Cl2, right? So your answer also accepted this. This is your answer scheme, which is also possible. Okay. So compare reactivity. This one is chapter 4 also. But how do we know? Okay. How do we explain this? Okay. Now, even for group, not only for group 1, group 17 same. Okay. So how to explain? Okay, group 17, right? Because normally if they have 7 valence electron, normally they tend to receive one more to achieve stable, right? So normally they tend to receive electron, then to attract electron. But which one will attract? Which one have the higher tendency to attract electrons? Which one have higher tendency? Let me see answer. F2. Yes, F2 attract more electron, actually. Tend to attract more. Why? Why so? Okay, how do we explain? Because you know, right? You must have this in your mind. You should have all. This is called inside. You have proton, neutron. You know, right? Inside nucleus, you should have proton neutron. So that's why proton is positive charge inside. It means in your nucleus got positive charge. Your positive charge will attract the surrounding electrons to enter. So that's why notice P, right? P, the distance between the nucleus and the valence electron is a bit, not valence electron, but valence shell. It's a bit shorter, right? Now this Q is a bit larger distance. Larger distance means the nuclear attraction force become weaker. It's harder for this nucleus to attract electron into the valence shell to become 8 electron. It's a bit harder for Q to do that. Not to say very, very hard, but harder than P. Okay. So normally fluorine is more reactive, right? I told you, the reactivity decreases from fluorine, chlorine, bromine, iodine. Fluorine is the most reactive, iodine is the least reactive. Okay. So you can say, okay, element P is more reactive. 1 mark already. I tell you first. Group 1, you got lithium, sodium, potassium. The most reactive one is potassium out of the 3 because the reactivity increases down the group 1. For group 17, you got fluorine, chlorine, bromine, iodine. Most reactive one is fluorine. Then the reactivity decreases down the group. Yeah. So the second mark, atomic size smaller. Okay. Normally you have to compare the size first. Doesn't matter. I told you, right? Doesn't matter boiling point, melting point, or chemical properties or reactivity. Normally you compare the size first. Which one's bigger, which one's smaller? P is smaller in this case. They even draw for you. So smaller because they have less charm, right? Less number of charm. So then you have to explain the nuclear attraction force. Yeah. If they come up 5 marks, then you can say the distance between the nucleus and the valence shell is smaller in atom P. Okay, this one, you just say nuclear attraction force towards electron becomes stronger. F2 is stronger. Size smaller, nuclear attraction force stronger. That's why P is easier to accept electron. I can say receive electron, same. Okay, to achieve stable octet electron arrangement. Because in this case, F from 2.7, it will receive 1 electron to become 2.8. So it becomes stable. Same thing, okay, actually same thing as Cl. We should also receive electron become negative ion. It's just that F will be easier to achieve stable. It will be easier to achieve to receive the electron. Yeah. Maybe this question, I don't know. Okay, maybe if exam, right, they just came out structured question. Then if they only got 2 marks or 3 marks, if they only got 3 marks, then I think it's the best for you to involve even if you can write everything, of course. But the important point is, which one is more reactive, of course. Okay, and if you 2 marks or 1 mark already, you take the third point. The third point, most important one. Yeah. Any question with this? Don't worry, I won't take too much time. Okay, don't worry. I just do 1 or 2 questions enough. Don't worry, this one I didn't tell you earlier. I very late tell you about this extra class, so it's okay. Other people can watch the video back. No worry, no worry. Yeah, it's okay. Maybe most of you have dinner. I know. Okay. Okay. So, but thank you for coming. For those who come. Okay. Yeah. Uh, can finish. Because exam is coming, so I do lah. But um, normally I won't do, but since exam is closer, maybe I'll do some revision. Okay. B, diagram 8.2 shows the electron arrangement of magnesium oxide. Okay. Now, this one is more towards like essay question. Okay. So they ask you to describe formation. Okay, okay, magnesium oxide. What compound is this? Who can tell me? We call it Sabatian. So it's ionic, right? Because it's got charge, got charge mean ionic. Okay. The metal, magnesium is metal, right? Magnesium metal. The metal will donate electron. The non-metal like oxygen will receive electron. But in this case, okay, or in Malay call it menerima electron, menerima electron. Okay, but in this case, because magnesium is 2 plus, it means magnesium has donated 2 electron to O. Okay, actually the diagram right, supposed to be like this. I mean, supposed to show the electron difference, but it's okay. Okay, so it means O, 2 minus means the O has received 2 electrons. Okay, so describe the formation of the chemical bond between elements of magnesium and oxygen in the magnesium oxide. Okay, so it means you have to explain donate how many electron, receive how many electron, what compound form, okay, attracted by what force. Also have to say lah. Okay, so first you have to talk about the electron arrangement. Okay, also very important. Okay, contain marks. So what is the electron arrangement for magnesium atom? Not magnesium ion. This one is magnesium ion. This one is already the stable version. I know it's 2.8, but the original is 2.282. Yes, the original is 282. So you talk about 282. And if they come out essay question, they will also ask you to explain like 5 marks, 6 marks, 7 marks. Okay. Then second point, around the same, but you talk about oxygen, 2.6. Original is 2.6. It's just that magnesium you donate to O2 electron. So the O, or you can say O receive 2 electron from magnesium. So it becomes stable. Become 2.6. I mean, not become 2.6, but original 2.6 become 2.8. Point 2. Point 3, you can talk about they are doing all this just to achieve stable octet electron arrangement. Now in SMA, I know essay question, we better don't write the point form lah. But now I show you because it's a bit tidier, right? I don't want to write the whole paragraph that is show the point. But exam I know lah, okay, the teacher somehow don't like point form. So don't like dot this, no dot all. Okay. To achieve stable octet electron arrangement, like because magnesium is 282, donate 2 electron, become 2.8. Same thing as O, 2.6, receive 2 electron, become O2 minus. All become stable. Now, number 4, talk about what? Talk about this one. How does Mg become Mg plus? Actually, the answer scheme is a bit wrong, but yeah, it's okay. Okay. Actually, this the third point should be at the number fifth, but it's okay. Yeah. So you talk about four and fifth first. Talk about atom. Okay, magnesium atom. Atom. That's why I tell you. You know the points, but sometimes you miss some words like magnesium atom because your school teacher very strict at this. Okay, if they see atom missing, then wrong. So magnesium atom donate two electrons. Actually, to be more precise, you can say two valence electron to form magnesium ion, which is Mg2 plus. On the other hand, oxygen atom accept two electrons to form oxide ion. The point number 4, number 5 here. Then the last point will be because these two ion, right? These two ion is, how do you say? One positive, one negative ion. So that's why they will attract to each other. And they will attract to each other. Okay. By what force? Important. That's number 6 point. Number 6 point is attracted by what force? Okay, electrons, the strong electrostatic attraction force. Yeah, so Mg2 plus ion, oxide ion, attracted by a strong, forgot to add. Sorry, I forgot to add in Malay. Daya tarikan electrostatic what? Okay, we call it strong electrostatic attraction force. Or we call it attracted by strong electrostatic force to form ionic compound. The final formula is MgO. Now I told you right because Mg is 282, O is 26. So Mg donate 2 electrons, oxygen receive 2 electrons. So when they cross, doesn't matter when they cross, it still become 2 2, right? 2 to 2. Then the formula, remember, right, is not Mg 2 2. No, okay, because 2 to 2, you simplify, become 1 to 1. So that's why the correct formula is MgO. I tell them. Ionic compound form MgO. There you go, all your marks. Actually, in assignment, if you get it, you put this point, achieve stable the point, you add it to number 4th, number 5th. Add to number 4th, number 5th. After this sentence, after the sentence, they donate electron to achieve stable octet electron arrangement to form oxide ion. Yeah, I add until I'll add here. Okay, but don't worry. Okay, don't worry. As long as you got a point. Okay. Also number 5th, you add around here. Yeah, because sometimes the problem is those answer scheme, right? They have a different kind of answer, so different ways to write it. So actually it's the same as long as you got the point. Okay, this one can. Do you have any question for that? Finish? Okay, so magnesium oxide exists as solid at room temperature. Explain why. Okay, so you can say, first of all, they say exists as solid at room temperature. Why so? It means they talk about what point? Yes, 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 yes. I saw a very good answer. Okay, so yeah, solid means they talking about why magnesium oxide not easily become gas, not easily get evaporated, because they have high melting point, boiling point. Very hard to get melted or boiled. Okay, first point, yes, very good. Okay, so melting point. Okay, we only talk about melting point because they're talking about solid. So it means they're asking why this solid haven't changed to liquid yet. Why can't change to liquid easily? So that's why in this case, melting point of magnesium oxide higher. Will be higher than room temperature. Of course, much higher. Okay, around few hundred degrees Celsius. Why so? Why is the second point? Magnesium oxide got what? More heat energy required. The point is number 4. Okay, you got 4 marks, right? So what's the second point? Magnesium oxide consists of what particle? What kind of particle? What type? Ions. So you should say consists of ions. They only talk about the force. What force do they have? They only talk about the heat energy. Need to have more heat energy. Yeah. Because essay question like this. Okay, so you must blow up more answer, more details. Okay, ions. Then number 3. Then we talk about what force. Just now we already wrote the answer actually, but it's included. Okay, so you have a strong. You can say electrostatic force in between ions stronger, very strong, because it's not only one ion. Do you know that? Okay. Do you think oh yes, I only got one Mg2 plus and O2 minus? No lah. Okay. So this one uh exists as like a lattice structure, like a cube shape. Okay. So it's not only one, and it's not only one. It's actually a lot of ions. Okay. Especially they are in solid. What happens is in solid, example okay, you got Mg2 plus O2 minus, Mg2 plus O2 minus. Doesn't matter. Let's say I am Mg2 plus, but surround me all attracted by O2 minus. Doesn't matter with top, bottom, left, right, in front, behind. All attracted by force. So imagine a lot of people crowded. Not only one, like hundreds and hundreds. So that's why the attractive force is very strong. Okay, that's why a lot of heat energy required to overcome the force. It means how do you turn the solid become liquid? You have to heat. Of course, you have to heat lah. Okay, you have to let the particle absorb the heat. But for ion, need to absorb even more heat for them to split, become liquid. Because you know that, okay, I talked about this also. Solid looking like this. This is solid. When you want to become liquid, what happen? you have to heat the solid. Okay, or you can say these solid particles have to absorb a lot of heat energy. Then only they can split. They can be distance apart, become liquid. Become distance apart, we call it overcome the force. Okay, just now, overcome the attraction, electrostatic force. But for covalent, it'll be easier. Covalent mostly like carbon dioxide, oxygen gas, methane. All these are in gas form. So it's why because covalent they only have. If they talk about covalent, your point is the weak van der Waals attraction force. Less heat energy overcome because they consist of neutral molecule. You know, that's why some question they can change. They can ask you ionic, they can ask you covalent. So you never know. Okay. Covalent, just change. Melting point, or can say boiling point lower. Consists of neutral molecules. Okay. Between the molecules only have weak van der Waals attraction force. A little heat energy to overcome the force. Just change. If you see like CO2, ammonia, this kind of thing, it's covalent already. Any point with this? None? Finish this one. I move on to one more question. Then we finish. I hope can will be helpful for Form 4, Chapter 5. I also did other question. Okay, again, I remind you, can check out. Okay, for objective and structure. I send the link again, just in case you couldn't find it. Okay. Question 10. Diagram 10.1 shows the electron arrangement of XY form, a compound. Okay. So explain again, they ask you to explain the position. Explain the position. Say contain 5 marks. Okay. So in this case, very easy one. What can we do is, okay, first of all, 5 marks means if 4 marks means the group explanation, period explanation. If they ask about 5 points, 1 more point is about the electron arrangement. So for X, okay, no, for X plus, sorry, there should be Y, right? Answer I give is X. Sorry, let's have to change, So it's supposed to be X. Typo. I am sorry. I need to change to X. Yeah. So X is 2 plus. It means for atom X ion is 2.8. Atom X is 2.8.2 because originally is 282, donated 2 electrons, become 2 plus, so 282. If they ask for Y, now it's also 28, right? Originally is 26. Actually, same just now, same as the magnesium ion, magnesium oxide. Okay. So we talk about this electron arrangement. Oh, but just now they asked is 2.7. Okay, now it's 282. 282. So what group one? And remember, for those who don't know, right, if you see 1 or 2 valence electrons, it's group 1, group 2. You know, right? Because if you see group the reason you see group 13 because if you got 3, 4, 5, 6, 7 valence electron, okay, you need to plus 10, it's group 13, 14, 15, 16, 17, 18. Okay. So this one is group 2. Okay. Group 2, that's why you got 2 valence electrons. The other point should be these three, isn't it? Okay. So you got three shell. Okay. Atom X has three shell filled in with electron. That's why it's in period 3. Always talk about the period, which is the horizontal row. You talk about the group, which is the vertical column. They ask for meaning also, so you have to know what's the meaning of group. Vertical column in the periodic table of elements. What is the meaning of period? Period is horizontal row in the periodic table of elements. Okay. But of course, okay, exam won't come out everything. They might even not in the prediction, not in the structure. I don't know, not in the essay. Okay, or it's possible also to have, but a bit different questions. Okay, of course, the question can be changed, like different kind of way to ask, but some of the idea is the same, some of the answer are around the same. I forgot to tell you, they will also ask for drawing. If they ask for drawing, right? So for ionic is you have to draw the already stable version. Like you don't draw the atom X. If they ask for draw the electron arrangement of this ionic compound, it means they want to draw the 2.8 one, not the unstable one. And you have to draw the square bracket, write the charge. Don't forget, okay? Okay, finish writing. The reason I do class because I know you're very lazy, or do video because I know you're very lazy. If you have no teacher, okay, so I teacher the month, they only can do. If I let you do, then you won't do. So very common. Because first exam, for sure, chapter 4, I mean, form 4 will come out, right? So you have to know lah. Okay, maybe next week I also give you the exercise of number of mole, all this, and breaker formula. Okay, can. Done? I move on already, move on to B. I give you 15 seconds. Uh, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. Oh, I believe your handwriting will be faster. Okay, so B. Okay, we want to save time. Okay. I also don't want to like keeping in gene for too long. Okay. So diagram 10.2 shows the chemical symbols which represent 3 elements P R. These letters are not actual symbol of the elements in the periodic table. Okay, so they ask for uh and between the element P and Q, draw the electron arrangement, and also using formation, explain formation. The point is they ask you to explain formation between P and Q and draw the electron arrangement of this compound. Now P and Q. P. What is the electron arrangement? You know what this number stand for at the bottom? What this number stand for? Anyone tell me? Atomic number. Kind of true. Okay. So electron number actually is proton. Number of proton. This one chapter 4, chapter 2. Okay. Number of proton. Yes. If exam they will ask you also to draw standard representation. So you have to write a symbol. Let's say, actually you know what is P. The top number is called nucleon number. Nucleon number. Yeah. Nucleon. Yeah, shit them. What shit? Okay. So in this case, okay, nucleon number. Okay. So then what is the electron arrangement? Now because they tell you all these are actually all these are atom. Okay. When they give you this, means they're talking about atom. So atom, that's why then only we say number of proton equals to number of electron. So what is the electron arrangement for P? (2.4). Okay, 2.4. Yes, 2.4. Okay. Now because you got 6 electrons, first shell, remember first shell only got 2 shell. I mean 2 shell, 2 electrons. They can be filled in. Second shell, maximum is 8 but 6 only so 6 is 2.4. What is the electron arrangement for Q? What is the electron arrangement for Q? This one don't even need 1 second. So it's 1. Of course, okay. 1 means 1. Okay. If they ask for R is 2.6. Okay. So, but they ask between P and Q. Let me ask you, these two, this P and Q, right? Consider what type of metal? Is it metal, semi-metal or non-metal? You know what is P? What is element P? For the actual symbol, actual element. Which one has 6 proton? Actually, P is carbon. Aluminium. Cannot be aluminium. Hello? 6 proton is carbon. 6 carbon is, 6 carbon plus 6 proton is carbon. Which one? This one? This one I'm sure you know, right? Q. Which one is the first one? This one you know, hydrogen. Okay. So R. Which one have 8 proton? Oxygen. It's some students confused. 8 proton is oxygen. If they give you like this one is sulfur. 16 proton is sulfur. Don't be mistaken. Quite similar, but don't be mistaken. So in this case, between them, what compound do you form? What bond do you form? They will form what bond? Covalent bond. Very good. I write down ionic is between metal plus non-metal. If you say right, metal normally have 1, 2, 3 valence electron. Non-metal have 4, 5, 6, 7. So then covalent, then only non-metal plus non-metal, which is 4, 5, 6, 7. Okay, your favorite number. Okay, so yeah. So any question? But you ask me, I thought Q is not 4, 5, 6, 7 valence electron. But Q, right? But this one is a bit tricky. Okay. So what happened is Q is an exception, except hydrogen. Hydrogen is not considered as group 1. Only after that is like lithium, sodium, potassium, they only group 1. Hydrogen is special case. Okay. So what happens? P will share, we call it Bergson will share how many electrons? 4. Okay. Because if P will share to Q 4 electron, as Q will also share back P 4 electron. Same thing, right? Covalent means you share me, I share you. Okay. So then Q only got one shell. One shell means you need only 2 become stable, right? So you only need 1 more. So that's why Q only share 1 electron to P. P also will only share back to Q. Only 1 electron. But P need 4 electron. Isn't it that's why you need how many Q to share to electron? To share 4 electron to P. Total you need 4 atom Q. Yes, 4 atom Q to share 4 electron to P. Then only P can stable. That's why normally if you don't remember this theory, normally what I can do is, normally you can just cross it, switch, okay? 4 to 1 become 1 to 4. That's why the formula is PQ4. They will ask you to describe and also the drawing. The draw also like this. Okay, this is the drawing. I mean, this one is the simple version. Okay, if they want to draw it, you have to draw like this. You have to draw. Actually, this one is CH4, methane. I'm sure you just learned Form 5, Chapter 2, right? Methane, CH4. Okay, so one like this, like this, like this, like this. But don't worry, you write first. Number 1 point, of course, the top of the electron arrangement. Okay, for atom P is 2.4, for atom Q is 1. Write down the electron arrangement first. The same thing for ionic covalent. They will ask either one. So if they come an essay, so they ask you to describe the formation of this compound. So either ionic or covalent. Remember, for the theory of metallic, hydrogen, and also the dative, I think I explained in the other structure question. Question 6, 7, 8. Okay, then number two. Number two, we talk about each of them, P and Q, right, contribute, you can say menyumbang electron, contribute how many electron to share? So you can say atom P contribute 4 electrons. Okay. And and each of the atom Q contribute 1 electron. I have to write each because it's not only 1 Q, it's 4 Q. But not everybody share 4 electrons. Each one of them share 1 electron. The result total you got 4 because you got 4 Q, right? So everybody donate, I mean not donate, share to him, share to the P 4 electrons. The writing got 4 marks, drawing got 1 mark. First point, electron arrangement. Second point, contribute how many electrons to share. Then, as we analyzed here already, each one of them contribute how many. The third point, you talk about the share. They share electron to form what kind of bond? Now, notice what kind of bond form? What is this name? Nothing to do with hydrogen bond. I'm so sorry. Okay. Hydrogen bond is between HF, HO, HN. Do you see? Okay, I'm sure you know. Okay, P is carbon, Q is H, right? Do you see FON? No. You don't see fluorine, oxygen, nitrogen. Okay. You only see carbon, I'm not carbon, carbon and H. So they won't form hydrogen bonds. Okay. I have another video for hydrogen bond, but no worry. Okay. So this one is called, all this bond is called, remember it's called, one line is called, one line, to be more precise. So the class is on day 10, right? The class we finish when this question, when this question finish. I don't know, only one more question later. Okay. Not solid one. Shit. Okay. I'm so sorry if I also a bit late already, but I didn't expect to do so, but okay. Okay, so yeah. But at the same time, I feel like doing one question is a bit too less. That's why I do two essay question. Okay, so this one is called single covalent bond. Ay, ay, ay. How many? Four. So it's you should say okay, the one atom P share four pairs of electron, to form four single covalent bonds. Even the drawing you have to know. Okay. This is the third point. The fourth point, you write the formula. The fourth point, what formula form? A covalent compound, PQ44. Yeah. So this writing, covalent must have this type of sentence. If they ask you to describe the formation, explain the formation. But today I mainly teach ionic covalent. So again, I mentioned hydrogen bond concept, other bond concept. Go watch the video. Okay. Because I don't want to drag too long for another question. I only do like let's say question for life because I can't do application. You also don't want to wait too long. Okay? So yeah, when you're free, then you go watch. Okay, so point five, drawing. Okay, so drawing, maybe I should draw for you lah. Yeah. So okay, what happen is like first of all you draw the P in the middle, right? You draw P in the middle. P you got how many shell? P is 2.4, two shell. Okay, one shell. One shell. Okay. Another shell. Okay, two shell. Don't forget, you have to draw Q also. Okay. Should I draw Q? Q only got one shell, Q only got one shell. But I got four, right? So I have to draw four. One. Okay. Two. Three. Four. Like that. Okay. Of course, you have to draw the electron also lah. Okay. So for P, I use cross, 2.4, right? But I know I already share the four electron out, right? Share to Q, right? So I got 1, 2, 3, 4 already share to Q. Okay. Then the Q also have to draw, right? But Q only one electron, right? Q only got one share one electron. So I already share to P, right? So it means outside no more. Outside is empty. Okay. So I share already share one to P. Each one same. Right? Drawing can I? Explain also can I explain? CH4. It's not that hard, right? What do you mean 完蛋了 What do you mean? Ionic covalent 吗 Can I? And this is our question, okay? They will ask, most probably. Can you show the top part of 5 seconds? Oh, okay, okay. Wait, like that, okay. Form chapter 1. Okay, lah, I do some question for form chapter 1. Maybe like around week 4 or April week 1. Okay, okay. Welcome, welcome. Okay. Then maybe I'll do because I would say form chapter 1 have the highest chance to come out essay. Since the chapter is hard, let to come out essay. So many cell. Two cell only mah. Electrolytic cell and voidic cell, two only mah. We got so many. Okay. Concept too many. Um, yeah, true. That part is a lot of things to memorize. Okay. Okay. Done, done, done. All this done. Last question, yeah. Last question that we finish. Okay. Diagram table 3 and table 1 show the apparatus setup and observation. Now this one, either the question ask you to describe the formation of bond or whatever, or they will also ask this, the physical properties. Okay, they will give you diagram, experiment. Normally, I tell you one more time, if they ask for ionic versus covalent, as here they did, okay, normally you have to know the 3 points for physical properties. Okay, or you can in Malay call sifat physics. Number 1 is solubility in water. This one I have to know. Okay, in Malay it's called ketelangtan dalam air. Which one dissolve in water, which one dissolve in organic solvent. In Malay it's called pelarut organic. Number 2 is electrical conductivity. Okay, for ionic and covalent. So condensate electric. Number 3, melting point, boiling point, high or low. Takat lebu, takat dede lebih rendah atau tinggi. So you got 3 points. Okay. So in this case, okay, here got 10 marks essay. Okay. So what they ask is they give you a experimental setup. Okay. One time, okay, I mean one time, like first time they put lead 2 bromide. Okay. Then they change the experiment with naphthalene. But if they use lead 2 bromide, they will test with solid and molten state. Okay. Okay, so they test solid, then to see whether they will whether they will conduct electricity or not. Okay. Then after they heat, the Bunsen burner to heat until these two become melted. Then you check whether the light bulb lights out. Okay. So as you can see, even the result told you already. Okay. So solid. This one is anyway, right? You know, because lead is Pb2 plus. Lead 2 ion and bromide ion. You notice this is ionic compound, right? Ionic compound very easy one. You already know that. Okay. Ionic compound, number one, for sure, just like I told you that melting and boiling always higher, right? First point. Second point, okay, they can dissolve in water. Not everyone, okay? Actually, not everyone, but most of them, yes, can dissolve in water. But lead 2 bromide cannot. Because lead 2 bromide, you learn in Form 4, Chapter 6. Okay, lead 2 chloride, lead 2 bromide, lead 2 iodide is an insoluble salt. But normally, like magnesium chloride, magnesium nitrate, sodium chloride, all this can dissolve, okay, in water. Then number 3, they can conduct electricity, okay, in molten state or aqueous solution. You know what is molten state, right? I told you, right? So molten state means uh, you heat the solid until you get melted. The hot liquid, we call it molten. And can conduct electricity in aqueous solution. Means you throw the salt into water, dissolve it. That solution, the salt solution can dissolve, which can conduct electricity. That's why notice solid state cannot conduct electricity. The bulb does not. Molten state, yes. Of course, covalent, no need to see it. Okay, both cannot. Okay, in all state. So they ask you to explain 2 points. 5 marks for electrical conductivity. 5 marks for melting point. Okay. So explain your answer, right? So what's the first point? First point is, okay, I read about the electrical conductivity first. First point, okay, we talk about the lead 2 bromide. Or you can write ionic compound. Same. So lead 2 bromide conduct electricity in molten state or aqueous solution. You know, actually, for electrical conductivity, okay, 2 points for the molten state. 1 point you talk about the solid state. Why no conduct electricity? Then the 2 point also for about the naphthalene. Why cannot conduct electricity? So for P2, okay, because consists of this electrolyte consists of free moving ions. Okay, your ion in solid cannot move, no freedom. Only when you dissolve in water or you call it become liquid, then the ion can move freely. Then the ion become active, can carry the electrical current, can then just move around. Okay. Second point. Third point. Third point. Talk about the solid state. Okay. Solid state does not have free moving ions. Already another mark. As you know, a solid particle very phantom. Between the particle, very hard to move around. No freedom. So that's why you have ion but cannot move. Okay. For the third point. Number fourth, number fifth, just talk about the covalent compound, which is we call it naphthalene. Naphthalene cannot conduct electricity in all states. I mean, you can say cannot conduct electricity in molten or solid state also. Fourth point. Covalent, we can call it naphthalene. Naphthalene does not conduct electricity. Doesn't matter which state. Why? Why so? Why do you think? Yes, contain neutral molecules. No charge at all lah. Neutral molecules. Very good, good point. Yeah. So already 5 marks. Can. Any question with this electrical conductivity? They might also want us in exam. Okay, this type of question also very popular. Okay. Okay. So first point and second point, talk about the electrical conductivity in molten state for ionic compound. Third one, just add in the solid state because no free moving ions. Okay. Then fourth and fifth, talk about the covalent. Why cannot conduct electricity? Because of consists only neutral molecules, no charge, no ions. Okay. Okay, 6, 7, 8, 9, 10 is about the melting point. Okay, it's about melting point. All done, all done. Okay. So melting point, how do I say? For okay, you can say. Okay, number 6, melting point of magnesium chloride. Okay, is higher than naphthalene. Okay. Magnesium chloride. Sorry. Why? Okay, I'm so sorry. I think the answer scheme got very wrong. I'm sorry. Maybe I typed wrongly. It's lead 2 chloride. It's lead 2 chloride or lead 2 bromide? Oh, okay. So I'm so sorry. I'm so sorry. So it's lead 2 bromide. Yeah. Yeah. In Malay, it's called lambum dual bromide. Okay. I'm happy to change. I am sorry. So this one is lambum dual bromide. Just write that one. Either you write lead 2 iodide or you write ionic compound. Same. No need to write so many. So lead 2 bromide. Okay. Why is it higher? Just like I told you the first idea, because of the strong electrostatic attraction force. Number 7. Number 8. Number 8. This one. Strong means you need more heat energy to overcome the force. Remember, it means the lead-2 iodide particles have to absorb more force, more heat energy. Sorry, more heat energy to distance the particle apart. We don't call distance, we call it overcome the force. Number 8. 0.9. Okay, talk about the naphthalene. Naphthalene, why melting point is low for naphthalene? Because attracted by weak, you can say weak van der Waals forces, or you can say weak intermolecular forces. Okay, same. Good. Okay, why? Okay, melting point of naphthalene lower. Okay, lower because the molecules are attracted by a weak van der Waals attractor. It means let's say this one is C10H8 molecule, another C10H8 molecule. Between them have a weak van der Waals attraction force. That's why weak means if you let's say these two particles are close to each other, like in a solid state, let's say if you want to split them apart to become liquid, very easy. Only heat a little bit, then already can overcome the force to make them distance apart. So you can say weak van der Waals forces, same. That's why little heat energy to overcome the weak van der Waals attraction force. Yes, any question with this? I think this point is so important if they come an essay. So you have to know how to compare melting point, boiling point, solubility in water, and also electrical conductivity. Normally they ask more about electrical conductivity or melting boiling point. But one of the year in paper 3, they came out solubility of water and organic solvent between ionic and covalent. I think it's 2024 paper 3 SPM. It came out. It came out chapter 5 experiment. Last year it came out okay, 2023 it came out magnesium plus hydrochloric acid. About the Form 4 chapter 7 rate of reaction experiment. 24 came out the solubility. 25 last year it came out. Let me think. Oh, yeah, the Form 5 chapter 3. You haven't learned. Form 5 chapter, I mean for paper 3. For AC, last year. Last year came out a lot of chapter 6. Heat of, not heat of combustion, heat of displacement. Is it displacement? Displacement or? I think it's displacement last year. Yeah, heat of displacement. Is it heat of displacement? Yes, yes. Last year, this one, heat of displacement. Yeah. Because I have copper to, the one last year I used copper 2 sulfate plus zinc plus magnesium plus aluminum. But exam they normally don't tell you copper 2 sulfate. Last year I remember the student told me the teacher just gave him the package and came out W2 sulfate. They won't tell you what's W, but the salt is blue color, obviously it's copper 2 lah. Okay. So and they won't tell you what is the powder. They feel powder X, powder Y, powder M, I don't know lah. Okay. This is what happened in exam. They like to give it unknown. Okay, can? Okay. Any question with this? Any more question with Form 4 chapter 5? Now I let you ask. If you need any explanation for any other part. Okay. No. Then I stop here already. Okay, I don't have to wait too long. Okay, after you finish copying, okay, then that's it for today. Thank you for coming. Okay, so I see you again next week. I mean, for the other lesson. Okay, see you again. Bye bye.